Graphing linear inequalities. So here's the less than symbol, but when you graph it in a coordinate grid, the first thing I want to point out is if you have a less than, this is going to be a dashed line. Or the way that I often say is if you don't see a solid line underneath that, it is not going to be solid, or in this case dashed. So a less than is dashed and it will be shaded below because all the values have to be below the line. The greater than is also going to be a dashed line, or specifically if you don't see a solid line, it will not be a solid line. In other words, it'll be dashed. And instead of being below, it'll be above. And I'll restate these once we actually get to some inequalities. Less than or equal to is because there's a solid line. It will also be a solid line when we graph it, and it will be below the graph line. The greater than or equal to, similarly, is a solid line. And again, the mnemonic is simply if you see a solid line, it will also be a solid line. And because it's greater than, it'll be above. And then just a quick reminder that typically in the past when we graphed equations in y equals mx plus b form, where our b value, this right here, this is our y-intercept. Or typically the mnemonic or memory device that I've said is that since it begins with a b, this is where we begin. The m over here, this is actually where we move, but really this is our slope, which is our rise over run. So there's kind of a quick review. Now let's do two examples together. The first thing I'd like to point out is that the number in front of our x, this is actually our m. So I'm going to simply put m is equal to 1/2 just to avoid any sort of confusion. My b value is to the right of x, so my b value in this case is -7. And then I do want to point out that this is a less than symbol, which means that it's going to be a dashed line, and it'll be below. And after we graph it, I'll come back to this and I'll be a little bit clearer with that. So let's begin by going on our y-axis to finding -7, which is down here. Put a dot there. And then I'm going to move with my slope of 1/2 by going up 1, right 2, up 1, right 2, up 1, right 2, up 1, right 2, up 1, right 2. And we'll put as many points as we can. Now the reverse to that, since this is a positive slope, would mean at our b value or y-intercept, I'm going to go down 1, left 2, down 1, left 2, down 1, left 2. And the reason we did the slope in reverse is we went from right to left, which means we'd have to accommodate that. So now I'm going to address this part right here. This part. So because it's a less than and it's a dashed line and it's below, when we graph this line, we do not want it to be solid. So I'm just going to go ahead and grab my pen here, and I'm just going to go ahead and put a dash of similar colors. So I'm just put a dash here, dash, dash. And as long as it's not solid, again, as you can see, my line is far from perfect, but it's going to be a dashed line. So there's the line, clearly shown. And now what I'm going to use is I'm going to go ahead and use that same highlighter where I put dashed and below, and I'm going to simply shade in everything that is below that line. So this whole region represents the solution to the inequality. In other words, any point over here we could actually pick, and it would actually justify the correct solution here. I do want to point out though, you could not pick a value that is actually on the line right here, because the value on the line is, you would be saying that it would be equal to. All right, let's go to number 2. Graph the inequality on the axis below. Again, the number here in front of x, if you don't see it, it's assumed that it's going to be 1. So I'm going to go ahead and put m is equal to 1/1. And then my b value here, I'm just going to circle it, that my b value is actually equal to 1. Because this is a greater than symbol, my greater than symbol is similar. It is going to be dashed, but it is going to be above because it is greater. So graphing this, I'll start at +1 because of my y-intercept, and then my slope is 1/1, so I'll go up 1, right 1, and I'll keep going up 1, right 1, up 1, right 1, as many times as the graph will accommodate. In reverse would be down 1, left 1, down 1, left 1. Again, put as many points as we can. going back to what we just discussed a moment ago, we did say that a greater than is dashed and above, so clearly it's a dashed line right there. I guess we could, if we wanted to, we could go ahead and add some points in between this like this, just to clearly show that it is not a solid line. That's basically just what you want to understand, is this cannot be a solid, because if it was a solid line, then that means that any value that you'd say is actually right on the line would be a true statement, but in this case it's not. All right, let's switch over to the highlighter, and it's going to be dashed and above, so I'm going to shade everything above this line to the best of my ability. Which means that any point found in this shaded region that is not on the line would actually be a value we could put into the original inequality. Okay, so we've got dash below, dash above. Let's see what we have. So we got example 3 and 4. Similarly, let's find our slope. So the slope right here, the number in front of my x is -3 halves. So m is equal to a -3/2. My b value right here is -1. Because it is less than or equal to, if there's a solid line, it will also be solid. But because it has a less than, it is going to be below. So going to -1, I'll put my dot there, and then my slope is -3/2, which means I'm going to go down 1, 2, 3, right 2, down 1, 2, 3, right 2, down 1, 2, 3, right 2. So this obviously is going to be a negative slope. The reverse to that is going to be up 1, 2, 3, left 1, 2, up 1, 2, 3, left 2, up 1, 2, 3, left 2. And I'd like to go up 3, but I'm off the graph, so I'll just stop at this point. Again, it is a solid line, so when I graph this, perhaps you want to like use your lanyard or something like that. And it goes pretty much like that. Grabbing the highlighter now, I'm just going to, again, restate that because it has an equal to, that's a solid line, and it is below because it's a less than. So we're going to shade everything below this line. Now the difference between this one and the ones that we graphed when we did not have a solid line is if we had to pick a point to prove that it worked, you actually could choose a value that is right on the line. Whereas before, because it was a dashed line, if you chose something on the line, it would not be a true statement. Okay. So there you go. So we can choose actually anything that is on the line or anything to the left of the line. All right, let's do our last one together. The last example here is the number here in front of x. I'm going to put a 1 there. So in this case, my slope is going to be m is equal to -1/1. So m is equal to -1/1. My y-intercept is +4. And then I'll start at +4 for my b value. And then I'm going to go down 1, right 1. And I'll keep going down 1, right 1 as many times as the graph will allow in that direction. Since I've run out of room going from left to right, I will now go the opposite, which means the opposite of down 1 would be up 1 and then left 1. And once I've graphed all these points, because it is a greater than or equal to, this will similarly be a solid line, and it'll be above. So switching over to my line function from here to here, and then we'll grab the highlighter, and it is solid and it's above, so I will shade everything that is above that line. But again, because it is a solid line, that means that a value, if we wanted to pick a point to test it, to prove that it would work in the inequality, we could choose actually anything on the line or anything kind of above the line. In this case, the shaded region works and anything on the line. And that's pretty much it. So just kind of a quick summary. What you want to do is remind yourself of these rules, whether it's going to be dashed and below, dashed and above, solid below or solid above, and then simply graph it into slope-intercept form. And that's pretty much the gist of the lesson. Finally, you can choose any point in the shaded region, and that would be a true statement. That would prove that you understand what you're doing.